In the previous session, we have looked at a brief introduction to graphs. Now here, we are going to look at what are the things that we can understand or try to understand when we look at a graph in the form of properties of graphs. So I'll be listing down all those things in the form of questions. So what does it look like? The shape of the graph is called a curve. Now, as far as mathematical sense is concerned, a straight line is also a curve. At what places on the x-axis does it cross? These crossing points are called x-intercepts. At what places on the y-axis does it cross? These crossing points are called y-intercepts. Where does the curve change direction or turn? How slanted is the curve with respect to the x-axis at any given point on the curve? This slant is called the slope of the curve. A straight line is a curve whose slope is constant over its domain. Remember, graphs are usually read from left to right, just as we read numbers on a number line. Which part of the curve is above and below the x-axis? Part of the curve is to the left and right of the y-axis. As the value of x gets bigger and bigger, what happens to the y value? So this basically means x gets larger and larger. Going where? Towards infinity. Now, as the value of x gets smaller and smaller, what happens to the y value? Now here, this means as x gets smaller and smaller, going where? Going towards negative infinity. As the value of x gets closer and closer to 0, what happens to the y value? Does the curve get closer and closer to a line without ever touching it? Such a line is called an asymptote. Depending on its orientation, it may be a horizontal, vertical, or slant asymptote. Is the curve continuous or non-continuous over its domain? That means, does the graph have any breaks or jumps? If yes, it is non-continuous, and otherwise it is continuous. Is it symmetric about the x-axis, y-axis, or the origin? Where does the graph attain its highest or lowest value, if any? So these are the kind of questions that graphs allow us to understand or answer. If we have an algebraic expression in x, we can graph it by introducing another variable y, forming an equation where y is the value of the expression for each value of x. So if you are given a expression, say x square plus 2x plus 3, then you just put another variable. Y is equal to that expression. Although graphs help us visualize expressions and equations, algebra and higher mathematics allow us to determine many of these properties without actually drawing the graph. And that really is the crux of the issue. Because whatever said and done, graphs have their own limitations. You can't keep scrolling up, down, left, right to go to higher and higher values of x. And interesting things may be happening at x equal to 1000 or x equal to 10,000. So because of that, algebra and higher mathematics provide us some techniques by which we can understand many of these properties or most of these properties without drawing a graph. So that was properties of graphs. In the next session onwards, we will look at graphs of some expressions or equations. That's it for now.